Welcome to Perimeter and Area, a comprehensive guide. This course module, Geometry 101, provides a complete walkthrough of formulas, diagrams, and step-by-step solutions for calculating measurement, 2D shapes, and complex compositions. We begin by defining the concepts. Perimeter is the continuous line forming the boundary of a closed geometric figure, analogous to fencing a garden, and measured in one-dimensional units. Area is the quantity of space occupied by a 2D shape, like tiling a floor, measured in two-dimensional units. The foundation of geometry calculation is unit conversion. Always ensure units match before calculating. Remember, converting area units requires squaring the conversion factor. For example, 1 square meter equals 10,000 square centimeters. Next, let's cover the square, a quadrilateral with 4 equal sides and 90-degree angles. Its perimeter is 4 times the side length, and the area is the side length squared. The properties of the diagonal are also provided here. In problem set 1, we find the cost of fencing a square field with an area of 5,184 square meters at $5 per meter. We find the side length by taking the square root of the area, calculate the perimeter, and then determine the total cost, which is $1,440. The rectangle has opposite sides that are equal and parallel, with all angles at 90 degrees. The perimeter is twice the sum of the length and breadth, and the area is length times breadth. Problem set 2 involves a nested shape problem. We calculate the area of a path around a 90 by 75 meter garden. First, find the inner area. Then, determine the outer dimensions, calculate the outer area, and subtract the inner area to find the path area of 1,750 square meters. For the triangle, the general area formula is half times base times height. This is valid whenever the height is known. The perimeter is simply the sum of all 3 sides. Problem set 3 asks for the altitude of a triangle with an area of 42 square centimeters and a base of 12 centimeters. By setting up the formula, substituting the values, and solving for height, we find the altitude is 7 centimeters. For advanced calculations, Heron's formula is used when all 3 side lengths of a triangle are known, but the height is not. First, calculate the semi-perimeter S, and then apply the area formula using S and the side lengths. Moving to the parallelogram, opposite sides are parallel and equal, and diagonals bisect each other. The area is calculated as base multiplied by perpendicular height. Do not use the slant side length for the area calculation. In problem set 4, we find the area of a parallelogram with a base of 24 centimeters and a height of 18 centimeters, resulting in 432 square centimeters. Then, using this constant area, we find the corresponding height if the other side is 20 centimeters, which is 21.6 centimeters. The rhombus is a parallelogram with 4 equal sides, and its diagonals intersect at 90 degrees. You can calculate the area using base times height, or half the product of the diagonals. Problem set 5 uses diagonals of 16 and 12 centimeters for a rhombus. First, the area is calculated to be 96 square centimeters. Then, using the Pythagorean theorem on the bisected diagonals, we find the side length is 10 centimeters, making the perimeter 40 centimeters. A trapezium or trapezoid is a quadrilateral with 1 pair of parallel sides. The area formula is 1/2 times the sum of the parallel sides, multiplied by the height. Problem set 6 involves finding the length of the other parallel side of a trapezium. Given the area, height, and 1 parallel side, we substitute these values into the area formula and solve, finding the unknown side is 7 centimeters. Moving to the circle, key constants include the radius r, the diameter d, which is twice the radius, and pi, the ratio of circumference to diameter, approximately 3.14. For circle calculations, the circumference, or perimeter, is found using 2 times pi times the radius, or pi times the diameter. The area, the space inside the circle, is calculated as pi times the radius squared. Problem set 7 provides a circular sheet circumference of 154 meters. We use the circumference formula to solve for the radius, which is 24.5 meters. Then, we use the area formula to find the area is 1,886.5 square meters. For parts of a circle, the area of a semicircle is half of the total area, and its perimeter is the curved arc length plus the diameter. A quadrant's area is 1/4 of the total area, and its perimeter is half of the circumference plus the radius times 2. The annulus, or ring, is the region between 2 concentric circles. To find its area, subtract the area of the inner circle from the area of the outer circle. The formula is pi multiplied by the difference of the outer radius squared and the inner radius squared. Composite shapes are made by combining standard polygons. Use the method of decomposition. Break the complex shape into known shapes. Calculate the area of each part individually, and then sum the areas to get the total. Problem set 8 involves a composite window shape, a rectangle surmounted by a semicircle. We calculate the area of the 2 meter by 1.5 meter rectangle and the area of the semicircle with a 1 meter radius. The total area is the sum of these two results. Perimeter and area have direct real-world applications in cost analysis. Fencing, framing, or bordering projects rely on perimeter calculations, while flooring, painting, or covering a surface require area calculations. This video has covered the fundamental building blocks of 2D geometry, from basic squares and rectangles to complex composite shapes. Practice is key to mastering these formulas and solving real-world spatial problems.